So today we will be discussing tall larkspur and crested floating heart. So the first weed of today is tall larkspur. There are many different larkspur species that are often divided into both tall and low groups. Tall larkspur itself is not a single species but a group of plants with similar appearances and habitats. Low larkspur is another group. Both tall and low larkspur are said to be poisonous or toxic to both humans and animals at varying degrees. Today we will be discussing a particular species of tall larkspur, Delphinium exaltatum, one of the most toxic, if not the most toxic species of larkspur. It is native to eastern North America, particularly in Pennsylvania, Ohio, south throughout the Appalachians, northern Alabama, and in various isolated populations in the Ozarks. Here in Figure 1, in a map provided by the USDA, is the distribution of tall larkspur in its native U.S. locations in green. The first discovery of tall larkspur dates back to ancient times. It was even mentioned in the Bible, believe it or not. Its common name is tall larkspur. The scientific name is Delphinium exaltatum, and this is an herbaceous perennial. Larkspur dates back to ancient times. Once again, it was documented in some detail in 1895 and was further documented in 1941 in Oregon. It was then given its taxonomic classification in the 1990s. U.S. locations of tall larkspur include Alabama, Kentucky, Maine, Maryland, Missouri, North Carolina, Ohio, the Ozarks, which are found in Missouri, Pennsylvania, Tennessee, Virginia, and West Virginia. Ideal weather conditions for tall larkspur include full sun to partial sun. This can be found in prairie remnants, dry, rich, open woods, and thin, rocky soil, which you may find in the Ozarks in Missouri. It may also be found in ravines, fens, thickets, and it is most common on calcareous soils. So, what are calcareous soils? Well, according to the Food and Agriculture Organization of the United Nations, calcareous soils usually have 15% or more calcium carbonate. This may occur in many forms such as a powder, nodules, crusts, etc. These calcareous soils belong to the calcosols and are related calcic soil subgroups. They are often found in drier areas. The high calcium in these soils tends to keep them well aggregated, but they may have an impermeable hard pan that requires deep plowing to break this pan. These soils usually have a low organic matter as well as low nitrogen. They are also lacking in phosphorus and micronutrients such as iron and zinc. Here in Figure 2 is an image of tall larkspur at the Ozark Riverways in Missouri on a thin, rocky soil type. Figure 3, right to the right, is an image of tall larkspur provided by North Carolina State University. The life cycle of larkspur includes blooming from July to September. These flowers appear in dense clusters along the tall stems, and the flowers are usually a striking lavender blue color, but they are occasionally found in red and white, white being the rarest of the colors. The structure of the flowers is a 5-petal-like sepal, one of which curves backwards, creating a spur, and this spur itself is how larkspur got its name. Figure 4 shows Delphinium exaltatum, tall larkspur, with its rare white coloration, and right next to it in Figure 5 with the red circles shows the spurs on the back of each flower on larkspur. Furthermore, on the life cycle, the flowers fade, the 3-section follicles will emerge, and each of these follicles or capsules will contain dark brown seeds. These seeds are small, but they are very poisonous, much like the rest of the plant, and they contain toxic alkaloids that are dangerous for both humans and animals. These plants will begin this cycle every single year as a perennial. They propagate primarily from seeds, but they may also propagate from rhizomes as well. Here in Figure 6 shows some seed stages of tall larkspur. In the top you can see the seeds, in the middle you can see the seed capsules or follicles, and then you can see the plant in its reproductive phase as well. In figure 7, it's just a zoomed in version of the seed follicles or capsules of tall larkspur. Identification of weeds. So tall larkspur is a dicotyledon or a dicot. It has a taproot system and its stem is rounded and hollow. This is a broadleaf weed with an alternate leaf arrangement, deeply lobed margins, palmately compounded, and attached by a petiole. Figure 8 shows the taproot system that you may find in tall larkspur. The red highlights the primary taproot. Branching off from the primary taproot is a secondary root, and then branching from the secondary root would be a tertiary root. And then even further down you have rootlets. Figure 9 is just a comparison between the taproot and fibrous root systems. In the left you can obviously see a taproot system, and the right would then be the fibrous root system, which we will find in crested floating heart whenever we discuss it later in this presentation. What areas in the U.S. and the world are affected by tall larkspur? Particularly the western United States experiences tall larkspur as an invasive species because it is non-native to these areas. It will affect high plains, foothills, and mountain ranges. And then worldwide, Canada is actually affected by tall larkspur as an invasive species. The severity of this effect is quite high, resulting in high loss of cattle due to larkspur poisoning. The signs of the weeds will occur through emergence with the two cotyledons. The stalk at the very young stage is a reddish-green base that tapers up to a light green in upper portions, but this red will only stay this way through young and early growth stages. As the plant matures, it will lose this reddish hue at the base, and it will simply just be a green to light green stem. The leaves are lanceolate to elliptic linear when young. As it matures, once again, it will become deeply lobed and palmately divided into 5 sections. The roots are fairly shallow, branching tap roots, and with an overall height of 6 feet tall or 2 meters, you wouldn't expect it just to have inches that root only a few inches within the ground. Figure 10 here is just an image of a more mature palmately compounded leaf of tall larkspur, and figure 11 is the underside of that same leaf. Economic importance for humans. Tall larkspur poses severe toxicity to us humans, which results in hospitalization and death. This severe toxicity also transfers over to animals and results in high livestock losses, particularly in cattle. This results in monetary loss to producers, yield loss in beef cattle, and in turn, less products for us consumers. It is poisonous to humans. So humans will experience a burning of the lips and mouth upon contact, numbness of the throat once ingested. Furthermore, you will experience intense vomiting and diarrhea, muscle weakness and spasms, a weak pulse, respiratory paralysis, then convulsions and fatality. Animals experience similar but slightly different symptoms, which include constipation and then colic. This colic is usually a result of the constipation, for there are only 3 types of colic, one of which is a constipation colic, and this is how this one occurs. Increased salivation, stiffness, weakness, convulsion, respiratory paralysis, which will eventually lead to heart failure and then ultimately fatality. The symptoms of poisoning are as a result of delphinine, an alkaloid, the main poison of larkspur. It is noted for its paralyzing action on the lungs and spinal cord, and these symptoms of poisoning are the same for all larkspur species, just in varying degrees. Delphinium exaltatum in particular is one of the most severe, if not the most severe. So, animals fall and struggle to rise. They may try to get up, walk away, and show no immediate signs of poisoning. However, later on, they will eventually stagger and fall down several times before paralysis of the lungs and death. These animals do not lose consciousness when paralyzed with the larkspur poisoning. Cattle will actually vomit, and then death will soon follow as a result of suffocation from the vomited material getting into the windpipe as a result of paralysis of various systems within the body. It should be noted that all animals that are poisoned are always constipated, and larkspur poisoning often occurs in overgrazed pastures. So there are a couple benefits to tall larkspur, such as its aesthetic appeal, which includes landscaping. Their height allows them to act as a natural barrier. They can also attract beneficial insects, which are your pollinators, such as your bees and butterflies. Negative effects would be severe toxicity to both humans and animals. They are fatal if ingested. Other benefits to tall larkspur include environmental benefits. They are a food source for your beneficial insects. They can help with soil stabilization, which results in reduced erosion and runoff, and they can be used in companion planting, which will aid in the growth of other plants. Negative effects furthermore include attraction of pests. Slugs and snails are common. Aphids, leaf miners, stem borers, and even spider mites are all common pests that will be attracted as a result of tall larkspur. Here in Figure 12 shows some of the pests attracted by tall larkspur. You see a snail on the left and a slug on the right. Figure 13 and 14 show both aphids and leaf miners respectively, which are also further attracted by tall larkspur. 15 and 16 show even more pests, which include this one in particular in Figure 15 is a rice stem borer. However, all stem borers of all kinds and species are attracted by larkspur. And the same goes for Figure 16. Spider mites of all species are attracted by larkspur. Mechanical control methods of tall larkspur include grubbing, which is the physical removal of roots. You may do this by hand, preferably with a shovel for small isolated areas, or for larger areas that are affected, you may have to use heavy machinery such as a tractor or an excavator due to its bucket or scoop. Chemical control is said to be the most effective means of control for tall larkspur. Silvex and 2,4,5-T are the two recommended chemical control methods. For Silvex, you would apply 4 pounds per acre in a liquid form, cover the entire plant, and apply prior to budding or at flowering. The same kind of concept goes for 2,4,5-T, however, instead of 4 pounds per acre, you apply 8 pounds per acre. Next, we will discuss crested floating heart. So, crested floating heart is native to southeastern Asia, particularly India, Vietnam, Taiwan, and southern China. It was first discovered here in the United States in Florida in 1996, and its common name is crested floating heart, with the scientific name of Nymphoides cristata. This is also an herbaceous perennial, much like our tall larkspur that we discussed earlier. Once again, it is native to southeastern Asia, but it was grown as a water garden ornamental, and it was intentionally introduced here in the United States in 1996. The species escaped cultivation in Florida. It invaded a neighboring lake in a residential area, and then it spread through drainage canals, which then spread to various other neighboring states. U.S. locations include Alabama, Florida, Georgia, Louisiana, Mississippi, South Carolina, and Texas. Now, it should be noted that crested floating heart is not native to the U.S. here at all by any stretch, unlike tall larkspur. So the effects that this plant has on native aquatic plants, animals, ecosystems, etc. is quite severe. Here in Figure 17 is a map from March 1st, 2025, very recent. It was provided by the USGS, or United States Geological Survey, showing some of the more popular locations of crested floating heart here in the U.S. Ideal weather conditions for crested floating heart is full or partial sun. They prefer a warm, temperate, or even a tropical climate, preferably temperatures between 68 and 86 degrees Fahrenheit. They like shallow standing water with a depth of about 1 to 3 feet deep. However, they can survive in water up to 9 feet deep. They like a high organic matter soil content, and sandy or silty soil is ideal. The ideal pH range is 6.5 to 7.5. However, it can tolerate acidic pH ranges. Crested floating heart likes slow moving, or still shallow water, such as ponds, lakes, reservoirs, swamps, rivers, canals. And here in figure 18, we can see crested floating heart covering an entire surface of water in Florida. This image was actually taken August 5th of 2009. And in figure 19 is a more recent image from a drone of crested floating heart covering a very large area of a water body's surface. Now, aside from the trees and shrubs that you can obviously see in the image, all the light green on the surface of the water is not algae, believe it or not. It is crested floating heart. The life cycle of this plant: it produces small oblong seed capsules. These capsules are less than 1 inch in length, and each capsule contains up to 20 seeds. It also propagates through stem and leaf fragments, and then germination and establishment occur. The plant obviously goes through a vegetative and reproductive phase. It also undergoes sexual or asexual reproduction. For sexual reproduction, pollination of the small white flowers on the surface of the water are pollinated, and this will eventually result in new seed capsules and seeds being produced. For asexual reproduction, stolons form new plants, or even fragments may break off and establish new colonies. Then we experience maturity and dormancy after a new colony has been established. Dormancy occurs in colder conditions, and this plant will enter its dormant phase and usually remain viable for the next season the following year. Crested floating heart is a dicotyledon, or a dicot, much like tall larkspur. However, instead of a taproot, it has a fibrous root system. Its stem is slender, round, and thin. This is once again a broadleaf weed. However, it has a rosette arrangement. Think of a rose, hence the name rosette. Its leaves do the same thing that a rose petals do. It has entire or smooth margins, and the leaves are cordate or heart-shaped. They are pinnately compounded and attached by a petiole. Figure 20 shows an image of a fibrous root system that we would find in crested floating heart. Figure 21 is the same image from before. It's just a comparison between the taproot and fibrous root systems. The only difference now is that we would be looking on the right side to see our fibrous root system of crested floating heart as compared to the taproot system of tall larkspur on the left. Areas in the U.S. affected include Alabama, Florida, Georgia, Louisiana, Mississippi, South Carolina, and Texas. Parts of Asia where the plant is non-native include the world areas affected. The severity of this effect is quite high. It's very severe. Rapid growth results in the crested floating heart plants covering the entire surface of water bodies. They shade out and outcompete native plants. The decomposing vegetation will negatively impact the water quality in native aquatic species. These excessive shading will result in severe decline in algae, and it will further disrupt the entire food web of the aquatic ecosystem. Signs of the weeds include bright yellow star-like centers in the white flowers, the heart-shaped leaves on the water surface. They will float on the surface. At young stages, they're very dark green on the top side, and they have a very strong purple hue on the underside. As they mature, it loses a dark green hue and becomes more of a medium to light green on the top, but still has a little bit of a purple hue on the underside. To me, I think it looks a little bit more red, personally. It will also have stolons or runners at young stages that appear to spread across the water's surface. Here in figure 22 is simply an image of the white flowers with their bright yellow star-like centers. That flower in the middle of the three, you can see it especially looks like a star, I think. And in figure 23, we have a more mature leaf. As you see, it's lost its dark green hue. It's more of a light, possibly medium hued green, and it even has a reddish brown ring on the outside of the leaf. Figure 24 shows the underside, and you can see that kind of purple reddish hue underneath. Further on sides of the weeds, they have tuberous propagules. They occur in small clusters that dangle from the nodes on the petiole and is helpful for the plant when it is not flowering. It may look like a small cluster of free-floating leaves on the water surface before rooting, but this is only in the case of the early growth stages. The economic importance for us humans includes a very high control cost, whether it be mechanical, biological, or chemical. Waterway obstruction occurs. This affects recreational activities such as boating and fishing, and as a result of that, we experience decreased tourism and a loss of revenue in certain areas. Crested floating heart will impact fisheries by altering the aquatic ecosystems and negatively impacting aquatic life and populations of plants and other fish species. It also causes damage to infrastructure such as clogged irrigation systems, and then that results in an increased cost for maintenance and repair. Property value will decrease as well. Now, crested floating heart is not toxic to humans or animals, however, it does pose an indirect effect to both animals and plants. It's reduced oxygen levels in the water. It poses altered habitats, disruption of the natural balance in aquatic ecosystems, and it shades out aquatic plants and other native species that other animals may feed on. Damage to the plants include competition for nutrients such as sunlight and space. The floating leaves will block the submerged plants from the sunlight, reducing their growth as a result of not being able to photosynthesize from the lack of sunlight. They will displace native aquatic plants, which will reduce biodiversity, and environmental chemistry will alter nutrient balance and cause eutrophication. This reduces the water quality and negatively impacts aquatic plants. The aesthetic value for water gardens should be noted for a pro of this plant. However, its invasiveness outweighs the aesthetic value of this plant, or weed is what I would call it. Its cons include the fact that crested floating heart is extremely invasive. It will densely cover entire bodies of water in a very short period of time. It will outcompete native species, particularly plants. It will impact the water quality, which will further impact native aquatic species such as fish and disrupt the entire food web within that ecosystem. There are a couple mechanical control methods, one of which is water drawdown, and this includes reducing the water level that reduces the viability of this plant because the exposure to air will eventually kill them. Another method is just mechanical harvesting, which is simply physically removing the plants from the water. This is not an effective measure because the plants can grow back from any fragments left behind in the water. Scientists suggest preventative measures, however, mechanical control is not a practical means of control of this invasive species. Biological methods are not officially known or said to be effective, but a few have been studied. Insect herbivores such as the leaf beetle has been studied as well as pathogens such as fungi or bacteria, and then fish such as the grass carp. None of these are effective measures of control, though. Chemical control is the most effective means of control of this invasive species. There are quite a few different chemicals that could be applied, with only 2 or 3 in my opinion being the best method. But to start, 2,4-D and indothal. Aside from concentration and the fact to which indothal is offered in a granular form as well, they essentially have the same application method. You apply them in the early spring at the first sign of new growth. The difference in concentration is 2 parts per million for 2,4-D and then 2 to 5 parts per million for indothal. For that, you would just follow the instructions on the bottle. You ensure thorough coverage of the plant and then repeat it 3 to 5 weeks after that first application if needed. For triclopyr and glyphosate, you apply both in the early spring during active growth. You apply either 2 to 5 parts per million concentration, ensure thorough coverage, and repeat 3 to 5 weeks after the initial application if needed. Imazamox is applied in the early spring during active growth. Concentration 16 to 64 ounces per acre. This is a foliar spray, and you must ensure thorough coverage, and once again repeat 3 to 5 weeks after the initial application if needed. Fluridone, apply in the early spring during active growth. This one is 5 to 15 parts per billion concentration. This is a liquid or granular form, and you ensure thorough coverage of the plant, but it has a very slow mode of action, and it is said to repeat as needed. Pinoxulum, applied in the early spring during active growth once again. Its concentration is 30 to 90 parts per billion. This is a liquid or granular form, and you ensure thorough coverage once again. And this is also a slow mode of action that is to be repeated as needed. Fluoropyroxafen benzyl. You apply it in the early spring during active growth. Its concentration is 10 to 40 parts per billion. This is a liquid applied as a whole lake or large area treatment. It has a static exposure time of 6 to 48 hours. These are my references. Thank you.